Hello again. Okay, so this time I would like to go over the graphing worksheet that you guys did, the graphing review. So I had a lot of questions about independent, dependent, and control variables. So I'm going to just give everybody this new example because I think this is the one that makes it the most simple, at least for me. So if it doesn't clear anything up, let me know, but I think this one will really help. So at least for the first 3 questions, we're going to use this example. So I'm reading up here. All right, you are growing 3 plants. They're all the same type of plant, all have the same type and amount of soil, and all are stored in the same environment. You are watering each plant daily, but with different amounts of water. So you give plant A 10 milliliters, plant B 20 milliliters, and plant C 30 milliliters. You want to know how tall each plant grows. Okay, so let's look at the independent variable. An independent variable is a variable that is manipulated or changed in an experiment. So this is what you, as the person performing the experiment, change. So in this case, you are changing the amount of water that is added to each plant every day, right? That's the only thing that's different between these plants. You're changing that between each plant. They don't all get the same amount of water. So a dependent variable is the variable that changes as a result of the independent variable. So this is what you are measuring during the experiment. Dependent variable is the result, or it's what's measured. So in this case, it is your plant growth because you want to know how tall those plants are growing based on the different amounts of water that they're receiving. And then number 3, the control variable. So a control variable is a variable that remains the same throughout the entire experiment. This is every other variable other than your independent variable and your dependent variable. Everything else has to remain the same. So I specifically said it in here. So it would be your type of plant, the type of the soil, the amount of the soil, the environment that the plant's growing in. You could even get more specific and say the type of the pot that the plant is growing in, the type of the water that you're getting it, whether it's spring water or tap water. There's tons of other control variables. So it's everything that remains the same. All right, now let's move on to a different example. Number 4 says a dentist wanted to determine what brand of toothpaste would make teeth whiter. He gave his patients Crest and Oral-B, and the patients brushed for the same amount of time and used the same amount of toothpaste, and they all used tap water and had their teeth checked on Monday. So in this case, our dependent variable, what are we measuring here? We're measuring how white our teeth are. So that is the goal of the experiment. That's what we're measuring. That's the result that we're looking for, how white our teeth are. The independent variable is what we're changing, what's different between each experiment that we're doing, and that is the type of toothpaste. So we're testing different types of toothpaste. So in this case, it's Crest and Oral-B. And then our control variables, everything that stays the same. So in this case, we have the same brushing time, we have the same amount of toothpaste, we have the same type of water, and we have the same time frame. So they're all being checked on the same day. All right, and then number 5. So now looking at dependent and independent variables on a graph. So if you guys watched me and Mrs. Keltner's video from Monday, I believe I posted it, we did dry mix. Okay, so dry, dependent, result, y-axis, mix, manipulated, independent variable, x-axis. Okay, so that's a really easy way for you guys to remember where the dependent and the independent variable go on a graph. So in this case, we're looking at dependent. So we think dependent dry, dependent result y-axis. So our dependent variable goes on the y-axis. So our y-axis is the up and down one. So our title here is words per minute. So that's how many words per minute depends on how many weeks of practice. So it is our dependent variable. So then our independent variable, which is our mix, manipulated independent x-axis, so it's going across, is weeks of practice, okay? So our weeks of practice is going to show our result. Depending on how many weeks of practice we have, that's going to show our words per minute. So our weeks of practice is what we're changing. All right, so on to the fun stuff where you guys got to graph. So we have this turtle that we're looking at. So I wanted you guys to graph this on a blank piece of paper, or if you wanted to challenge yourself, I wanted you to try and figure out how to do it on Google Sheets. So we have this data set, we have the time and the position of the turtle. We first need to talk about the dependent and the independent variables. So in this case, the dependent variable is the position that the turtle is in. The position depends on the amount of time that he gets. It's also, if you think about it, when we make tables like this, let me see if I can, let's do it this way. When we make tables like this, we always have X and then Y. So you can make those imaginary columns, and X is always on the left and Y is always on the right. So that's an easy way to remember it too. So Y is our position. So that is our dependent variable. And then independent variable is the time clocked. So we decided on the time. Okay, we used the stopwatch. We decided that that's kind of what's changing. And that is the mix. So that is on the x-axis. So it's manipulated. It's our independent variable. Okay, so then you guys had to take all of that data and you had to graph it. So down here I have my graph, and this is one that I made in Google Sheets. Next week I will be showing you guys how to do that. So this is what your graph should have looked like. So hopefully your the ones that you did on the paper look similar. And we had this question down here. So step 5 says, was there ever a time the turtle stopped and took a break during its journey in the 80 seconds recorded? If so, how do you know? So we can see this spot right here where the graph flattens out. So the turtle stopped to take a break between 20 and 40 seconds. And we know this because his position did not change during that time. He was constantly at 20 centimeters. Okay, so that flat line there shows that we don't have a change in position over that course of time. Okay, so again, I hope this helped cleared up any questions that you guys had about the graphing review. If you still have questions about independent or dependent variables or anything else on this worksheet, just send me an email.